My name is Chris Laffey. I am a senior product strategist with Lenovo, and I get to talk to you about fun things, all right? For some of you who have been able to talk to us so far, we are making a product announcement. But just to level set a little bit, I've been working with hyperconverged now for the last 13 years and have evolved with the opportunity. And Lenovo and Scale have been together working these opportunities for the last 9 or 10 years. So we've been kind of conjoined at the hip. We've had a joint go-to-market. We've been doing a number of different things to make sure that we're getting you, our customers, what you guys need for hyperconverged. But the edge is different. And as we're driving out to the edge, it's not just smaller, faster, lighter. It's evolving the footprint and making sure that we're meeting the workload needs as they're evolving at the edge. Whether that's computer vision, it's AI inferencing, it's making sure that we're providing the power and depth to overcome some of the smaller, faster, lighter, and budget envelope that y'all looking to function in that we really haven't been able to meet with enterprise class data center servers. Been able to do it with NUCs, but they haven't given us the enterprise control or the management capabilities, out-of-band management capabilities, reliability, and depth that you get with enterprise class gear at the edge. So to overcome this, I have the opportunity to show off our new SE100 server, okay? So out of the box, first off, hybrid processor. So 6 performance cores, 8 efficiency cores. GPU and NPU directly on chip. So even when you start, you don't need this sidecar on it with a GPU. You're getting GPU capability 95 tops out of the box, right? What does this allow us to do? This allows us to serve these new inferencing workloads, these new computer vision workloads, and these new aggregated spaces in a much differentiated manner. Does this look small and light? Yep, it is. Okay, without the sidecar on it, this is an A1000 GPU on the side here, it's about 6 pounds, all right? We can put these in form factors, which we'll get into, that are very, very differentiated from what we've seen and what we've done in the past. That small form factor allows us to mount them anywhere, under a desk, on a wall, on a ceiling, in your traditional racks. The other thing that's important is that when you think about the core server, which you see over here on the left-hand side, a lot of times when you buy small devices, you are specifically contained and constrained in that small device. No scalability, no personality change, no structural change at all. But as you can see on the right, we can change the personality of the system, whether that's with a GPU, a networking card, or an industrial I/O card. This allows us to meet our customers where they live. How do you want to operate? How many people have heard about the convergence between IT and OT, right? Where OT industrial environments are now requiring more enterprise class gear to operate. Safety, predictive maintenance, quality assurance, all of these things that people are looking for. This allows us with the I/O card to go ahead and reach into those spaces. And we know that the edge is diverse, it's distributed, it's harder to manage and maintain because traditionally you're not going to have the hands and feet on-prem to be able to deliver the resources. So we've got to give you new ways to control it. We've got to give you new ways to manage it, new ways to maintain it. Because the data that we're collecting at the edge is going to drive the learning, that's going to give us the power to inference and retrain those models and really bring and democratize AI, which really hasn't been talked about. We used to say, 10 years ago, 12 years ago, when you ask somebody what the cloud is, you ask 10 people, you get 15 different answers. Right now, if you ask most people what AI is, they'll just tell you it's ChatGPT. But we know that the business cases that we're driving with AI and inferencing are going to be game-changing. My wife, who I enjoy talking about, is Chief of Staff for Human Clinical Research at the largest research facility in the country. They're doing things like genome testing and digital twins for diseases, and are treating those diseases before they even get into the field. So we're able to do human-changing things and game-changing things with AI, and once we train it and learn it and continue to refine it, we're going to get better outcomes. This is going to help us to attach to that data and deliver that data back to our learning facilities much easier and drive those new and differentiated outcomes. And when we talk about new and differentiated outcomes, it comes down to two true pieces. One is workload consolidation. We don't need a silo per application, all right? The tech debt that we've been driving in by having silos per application is just insane. We want to make sure that we can serve multiple workloads on a single cluster, or at least a couple of devices to make it happen. The other thing is acceleration. These are some of the flavors of AI that we're talking about. Computer vision. Yes, there are language models, but we're not talking about large language models. We're talking about targeted language models traditionally on a per vertical basis, where we're going to be narrowing down from the 4 billion models down into maybe a few 100,000, maybe a couple million, and make it easier to manage, maintain, and respond to. But it's the object detection, safety in the OT spaces, or smart cities. I talked about this yesterday when I was with the Scale team. For a long time, we joke around, hey, it's IT, we're not saving lives. But we have smart cities out there where we're monitoring things like first responders, traffic accidents, accident recreation. We operate in Santiago, Chile. They were running their marathon. Guy collapsed. We were able to get responders to him immediately and save the guy's life. So if we're going to assist in human evolution and drive human evolution with technology and compute, we need to be right where the data is being created, right where things are happening, and drive that interaction in a real-time or at least near real-time experience. When we look at democratizing this and we look at bringing this to the masses and making it accessible, we need to bring both of those tenets onto a single device and drive those outcomes from a single cluster or at least a single device. We can't have a 3-node cluster step-in cost being what it's cost us in the past. We've seen that, $28,000, $30,000, $35,000 for a traditional hyperconverged cluster. We need to bring that down by a factor of probably a third to make it effective. If we're going to unlock the workloads and we're going to unlock the opportunities, we need to make sure that it's accessible from a budget envelope. So we have the larger servers that we've been working with Scale for a long period of time. Our 2U server, our 1U server, and this is really going to round out our portfolio at Scale to be able to deliver in that smaller form factor, smaller, faster, lighter. We have a whole portfolio that we've been driving around edge consumption for a long period of time. What we really want to do is function from that SE30 level up, and we're exploring some of those with Scale now, and you'll see some announcements from, actually you saw some of them on the roadmap earlier today. But really, we need to be a foundational piece of hardware that can reach across all of these different verticals. I used to work for a guy who told me that the edge is the only horizontal vertical. These foundational pieces need to be able to serve across multiple purposes, and this is why we personality those devices. We're going to see in manufacturing that OT space when we're connecting to SCADA, CAN bus, Modbus, right? Where we're aggregating sensors, where we're looking at predictive maintenance. When we're in a lab facility, I love talking about this. We were talking to a microscope company who wants to utilize our server as the foundation for their software and be in labs all over the world. We want to collect the data. When we think about retail, we want to be able to do things like loss prevention, POS, self-checkout, all of the things that you've seen that's come in the evolution of retail. If you're talking to retailers, and I've seen this a million times, they'll tell you we want to do the store of the future. We want to modernize our infrastructure and modernize our stores. Until you put a quote in front of them. And then they go, okay, we'll just do what we've been doing. because the margins are so thin and their spend is so light that we need to not only design for the workloads themselves, but we need to make sure there's no extraneous stuff in the server that drives the cost of that server up to make it inaccessible for people. I love talking about oil and gas because there are so many different edge states within oil and gas. From collection derricks and platforms and oil sands through pipelines and refineries to logistics and shipping and transport to gas stations. And we can help them standardize their footprint on a single device and drive those outcomes and drive that simplicity that they've been looking for that nobody has been able to serve them with in an affordable, performant, functional device. So, some of the features. First, out of the box, I mentioned 95 TOPS. But if we put a GPU on that, and we've got the RTX 1000, 2000E, and 4000, we can drive another 300 TOPS through the system. One of the cooler things about this device, if you haven't seen it, when you look on top, you will see the fans are on top of the device, not inside of the device. It's 100% sealed. This makes this IP50 rating. We're not pulling grease and dust through the system. We're dispersing this like we disperse heat in a heat sink on a CPU. The heat cloud is going up and out. These fins allow for somebody to put something on top of the system and it still be able to cool itself. Also displayed here is one of the cooler features that we're working with, and that is a 1U 3-node system. This is a hyper-converged cluster in a 1U footprint. Smaller, faster, lighter, easier to consume, easier to pay for. Another really big feature with these fans is they're broader. For anybody who whistles, you know the smaller the aperture that you blow wind through, the louder the system gets. If anybody's heard some of the edge systems and small form factor systems that are out in the marketplace, you turn it on, it sounds like a Learjet taking off right next to you. Including some Lenovo's. Absolutely. All right? 35 dBA. Okay? This is quiet. It's about what your living room is when there's not much going on in it. Another important piece, that power consumption with GPUs is still sub 140 watts. Plug it in anywhere. Don't worry about it. We talk about the personalities and the ability to adjust. I mentioned the three of these. The RTX cards, the discrete GPUs. I mentioned the industrial cards, but also networking card. So if you're utilizing this as a security device, a gateway, an appliance, we're able to personality it so it's able to utilize, 10 gig networking, for example. But these mounting options really are a game changer for a couple of different reasons. The first is the 1U 3-node enclosure is something that, in the time that I've been working in hyperconverged, I always forget not to hit the mic. People have been asking us for. Get it into a small footprint, get it into a small budget envelope. Even with the sidecar on it, if you add GPUs or you add the networking cards, we can still fit 2 of them in a 1U footprint. That means that we can do a 4-node cluster in 2U. 4-node cluster with 400 AI TOPS per system is 1,600 AI TOPS in 2U. I'll challenge you to go find somebody that can do that for you today. This is game changing. But what people forget is, if you're going to build a cluster, they always don't have to be side by side. They have to be well connected. So if I want to put these servers right where the data is created and get low latency and quick response, I can use these DIN rails and these VESA mounts to distribute them out throughout an environment. Retail, for example, I can put one front of store handling POS. I can put one over a high value area and look at the high cost goods for loss prevention. And I can put one in the deli and look at the refrigerators or whatever the case may be, the cooled units. And as long as they are well connected, 10 millisecond round trip, they can still be used for high availability and fault tolerance. kind of cool, right? So I've been asked to do a couple of use case visualizations. And this is a traditional config. As a matter of fact, it's one of the configs that are being tested between our two organizations right now. You'll see 64 gigs of memory. You'll see a couple of 980 gig storage drives that match the boot drive, so we can share throughout all of them. Those are not the largest drives that we can put in there, but they meet the need for what we're looking at. With Scale on the system, operating on the system, now when we look at the cluster utilization, we can provide that workload consolidation, even without a GPU. High availability. Okay? We were talking about retailers before. This is a game changer for retail because they've said, we'd love to have fault tolerance and high availability in our environment, we just can't afford it. It's a need to have, it's a nice to have, but we can't do it. This gives them the ability to reach into that. The BMC out-of-band management is a huge piece, because if you're not going to have hands and feet on-prem, you still need to orchestrate, automate, manage it, lifecycle manage it. And having that out-of-band management, that xClarity controller directly on board, gives us the ability to do that. Lower step-in cost. I'll repeat that all day long. Okay, that's like my new refrain, right? 16 to 32 applications. Okay, when I'm looking at a 6-core, that's 12 threads, that's 2 vCPUs per thread, do the math. We can spread that across the cluster, get 16 to 32 applications. So if we're thinking about a remote office, which is one of the neglected areas of the edge, now we can provide things, domain controllers, ERP, EMR type interfaces. We can provide computer vision and security for the premises. We can also do the things that need to be done just for the care and feeding of an office, file and print, right? On this footprint, and serve it and have that entry cost still be third of what we've seen in the past. Retail, I can't tell you how many retailers I've spoken to over the last 8 years. And one of the biggest things that they tell us is, one, these systems get kicked around. All right, if it's under a desk or it's under a register, people knock them around, they get knocked down. So having that DIN rail and being able to mount it underneath it, that is critical. But fault tolerance, high availability, that store of the future. We did a study with one of the big box vendors where, and anybody who's bought an appliance at a big box vendor knows this annoyance. If an employee came up and interacted with a customer within 5 minutes in the washer dryer section, for example, their sales went up 25%. That means that you're not walking out of here going, nobody came and talked to me. So there are things that we can do to increase profitability and drive ROI immediately. Distribution and warehousing. Since the supply chain interruptions that we had a few years ago, people have gone to large-scale distributed warehousing, putting it in region instead of having large centralized pieces so that they can, deliver faster. They can also make sure that there's redundancy in the system. But things like WMS, EDI, some of the robotics that they're doing, some of the RF feeds that they're doing inside of warehouses require some of these newer type applications and these newer type inferencing pieces that we're able to deliver either with or without GPU. There we go. Safe and smart infrastructure. We rolled out in Barcelona, Spain, where we're on just about every corner managing their traffic lights, managing threat detection, so forth. This is a huge emerging area. We've also been talking to a number of cities here in the States and internationally to make sure that we are allowing for ISVs like Cognition to come to bear, to do some of these newer things that are necessary with traffic control and accident recreation and pedestrian management. Smart hospitality. Anybody notice all of the signage and all of the games and stuff that are running inside of this building? When you look at one of those gaming circles, I guarantee you that there's compute in the center of that that's operating and managing all of those. And it's feeding up to a centralized fabric controller which is allowing them to manage and maintain. There is RF all over these places that can help track people and also drive advertising directly to them based upon what they're doing. That gaming card that you have that you swipe in the machines, these are all things that need to be managed by edge compute. Branch office, we spoke a little bit about robo, but it's important to note, one of the biggest pieces of a distributed compute fabric, which is what we're creating here, is centralized management and control. Near zero touch provisioning. By the way, I don't believe in zero touch provisioning. People will tell you whatever. You have to condition things to make things happen. But that no local IT support and having centralized management and centralized automation, being able to spin up and spin down applications or redeploy golden images consistently to make sure that you're running in the way that your home office wants you to.